Hello, this is a recording for the simulation of the project PDE 4515, and as Group 3 member, I will explain how it works. We shall start the simulation. I shall push the stop button to make sure that everything is back to the initial value. As you can see on the station status, it changed from yellow, which indicates the standby condition, to the ready one. I summoned 3 workpieces as well as 2 caps for our simulation. And now we shall start. So the first workpiece being pushed to the right position to be gripped by the gripper. And as you can see, station 1 is now blinking green, which means that the station 1 is being processed. So now it will put it on the conveyor that is station 2. And station 2 should be blinking once the conveyor will start. And as you can see, now it's station 2 turn to blink. The capping process. So we expect that the black workpiece should be conveyed to the second slide, the middle one. It's being now color sorted and conducted to the second slide. Now the next workpiece would be silver one. The same process would happen again. We expect that for 2 workpieces, the first 2 workpieces, the capping process should be done. So that's the second one, station 1, then station 2 on HMI, the capping process again. So the silver workpiece needs to be conducted to the first slide. So the conveyor would start. It's now being color sorted. The separator will conduct it to the first slide. Now is the last one, the red workpiece. We won't expect any capping process. So actuator for the third workpiece should not work. So the same process would happen. Conveyor, stopper plate, and it shall let it go. So as you can see, actuator didn't do anything because it was the third one. And it will conduct it to the last slide. So here we got the physical station. As you can see, each of these stations are connected to iLink master. The first one is actually connected to main PLC, and as you can see, it is connected to the iLink master module using the green cable, and the other cables would be for connectivity of smart LED and the other 2 stations. So once we get all the terminals input and outputs, we need to convert them using another module known as a smart hub, which could convert all of these inputs and outputs into one single cable can be recognized by iLink master. So as you just watched out, all of these processes will be repeated same as the simulation that I explained earlier. 2 workpieces needed capping, so the capping process has been done, but except the red one, which is for the last slider, and it didn't need any capping. So the main objective of this project was to reduce as much as PLCs as we could, because beforehand it used to utilize 3 PLCs per each stations, but now we managed to replace them with one IO-Link master module, which allowed us to control all of these signals input and output I/O links by this module connected to just one PLC. And all of them could be easily defined on TIA portal for the tags that could be specified whether they are digital or analog, or they needed some configuration, for example, for the smart LED or other modules that are connected. So thank you so much for watching.